Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 11th, 2025, so just yesterday. This paper introduces a framework that can generate multiple, complex visual effects in a single video and control exactly where those effects appear, a major challenge for current models. The paper is titled Omni-Effects, Unified and Spatially Controllable Visual Effects Generation, and the visual results of applying multiple effects at once are really quite striking. The authors achieved this using two key innovations, a LoRA-based Mixture of Experts and a Spatial-Aware Prompt, all trained on a new, custom-built dataset. Also, the authors shared their full implementation on GitHub. For anyone wanting to experiment, it's a great resource. You'll find the source code, their new Omni-VFX dataset, and pre-trained models. They even have scripts ready to go for generating both single and complex multi-effect videos right out of the box. On their Hugging Face page, you'll find model checkpoints, including a fine-tuned CogVideoX 1.5, plus usage examples for adding and spatially controlling single or multiple visual effects. Alright, so let's look at what this Omni-Effects framework can actually do. The figure here shows its capabilities, starting with basic prompt-guided effects, like changing a summer scene to winter. It can also handle multiple effects at once, for instance, making a person fly while the background changes to spring. But the real breakthrough is the spatial control. Using the Spatial-Aware Prompt, it can target an effect, like making a coconut explode. And most impressively, it can manage multiple, distinct effects on different objects simultaneously, like making one bear levitate while another one melts. But to really appreciate what Omni-Effects accomplishes, it's useful to see the specific problems it was designed to fix. This figure highlights common failures in existing models. For example, when you ask for two effects at once, like dissolving a man while adding snow, one of the effects might just disappear. Other times, the model gets confused, resulting in bizarre artifacts, like these hands appearing instead of a crushing effect. And finally, there's the problem of spatial uncontrollability. When asked to melt only the left man, the model ends up melting both. Alright, so this diagram shows the core architecture that makes it all work. The whole system is built around two key components. First on the left is the LoRA Mixture of Experts module. Think of this as a team of specialists, where each expert LoRA is trained for a different visual effect, and a router directs the work. This prevents different effects from interfering. Then, on the right, is the Spatial-Aware Prompt, which includes the Independent Information Flow module. This part is crucial for spatial control. It uses a special attention mask to keep the instructions for each effect completely separate. Building on that architecture, this figure really visualizes why the Spatial-Aware Prompt with Independent Information Flow is so critical. The attention maps on the right, which show where the model is focusing, tell the story. In the top row, a simple text prompt fails because the model pays attention to both birds. The middle row uses a method called ControlNet, but the effects leak into each other, creating a messy result. But in the bottom row, the proposed method works perfectly, cleanly melting one bird and exploding the other, because the attention is correctly separated. Moving to the quantitative results, this table compares the proposed LoRA Mixture of Experts against other methods for creating single visual effects. The authors used two main metrics: Fréchet video distance, which measures overall video quality where lower is better, and dynamic degree, which reflects motion intensity, so higher is better. Looking at the averages, the LoRA Mixture of Experts approach clearly wins, achieving the best video quality and motion scores, all while using far fewer parameters than training a separate model for every single effect. This really shows how effective the architecture is. This table then details the more challenging task of generating multiple effects at once. The authors used two new metrics for this: effect occurrence rate, which checks if the effect appears at all, and effect controllability rate, which measures if it appears in the right spot. The results are pretty dramatic. The other methods, like CogVideoX and WAN 2.1, score close to 0 on both of these key metrics. They just can't handle the task. In stark contrast, the proposed model achieves much higher scores, showing it can successfully generate and control multiple effects simultaneously. So to wrap up, the Omni-Effects framework is a major step forward. By combining the LoRA Mixture of Experts with the Spatial-Aware Prompt, it successfully generates multiple visual effects in a single video, and crucially, gives the user precise control over where those effects happen. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.